Hello and welcome to this episode of SPSS one-on-one series with Owori Analytics. Today we look at correlation analysis practically in SPSS. We are going to look at Pearson's correlation, Spearman's correlation, and Kendall's Tau correlation analysis in SPSS. So let's get started. We are going to use a data set called the car sales unprepared dataset that comes pre-installed with the SPSS. I've also included a link in the description of this video where you can download this dataset to follow along with us. So to run a correlation analysis, first check normality assumptions. Draw a scatter plot, and you can optionally add a line of best fit just to have an idea of the direction. Then run the correlation itself. Then interpret. We are going to assume that our data has passed the normality assumption. We have a previous video on how to check for normality. The link is on top of your screen. You can check it out. So we are going straight to drawing a scatter plot, after which we shall run a correlation and interpret. So in this data set, we are focusing on two variables, that's sales and the price of a car. We want to see, is there a relationship between the price of a car and the number of sales for that car? Both are numeric variables, so a correlation would be appropriate for this analysis. Like we said, we've assumed both variables are normally distributed, so we are now going to get a scatter plot to have a visual look at our variables that we want to assess the relationship. To get the scatter plot, simply go to Graphs, Legacy Dialogues, and then select Scatter Plots. Select the simple scatter and then click on Define. We shall put price in our x-axis and then the sales on our y-axis. We want to see if the price changes in price, do they result in changes in sales of the cars? Then we click OK. We shall have our scatter plot that gives us an idea of, you can see there is some kind of pattern. You can as well optionally add a line of best fit, although it is for regression, but it will at least give you an idea of how this trend looks like. To add a line of best fit, simply double click in the graph to activate the chart editor. Then you use this button here to add the fit line at the total. Like I said, this is for regression, but just gives us an idea of the trend of our data. Then close and also close the chart editor. You will have your line there. With this line, I can see, okay, I have a rough idea that as price increases, the sales of the cars decrease. So we can now proceed to go and run the correlation analysis. Okay. In correlation analysis, simply go to Analyze, Correlate, and then go to Bivariate Correlations. So put these two variables, sales, under the variables box, and also price in the variables box. Under options, we don't need anything. We can have the means and standard deviation statistics, whatever you prefer. We can also have the confidence intervals. Okay, can click and continue. Then under correlation coefficients, select the Pearson's correlation. Remember, we said we have assumed that our data is normally distributed. With that, just click OK. So you will have some descriptives here that shows you the total number. In this variable sales, we have 157. Their mean is this, and standard deviation. We also have the price. Total number is 155, which is less by 2. Indicating that we have some two variables that have missing data. At this point, I expect you to have cleaned your data, but if not, you use this opportunity to go back to your data and identify those that are missing and see whether you clean them out or check your questionnaires to see whether they were just missed out. So the next table is about the correlations. You can see we have correlation of cells versus cells is 1 because it is correlating with itself. If you plot values of cells against values of cells, it is a perfect line. Okay? But we are interested in cells versus price. You can see here the value is 0.305, which is a negative. Remember, in our previous episode, we looked at interpretation of a correlation coefficient and using guidance from Colton 1974 as a crude rule of thumb, where we look at if it is between 0 to 0.25, that's little or no correlation. In this case, ours lies between 0.26 to 0.5, which is a fair degree of relationship. So this is the correlation coefficient, which is a negative, indicating a negative relationship between sales of cars and their prices. As the price, as one of these variables increases, one reduces. We saw that as price increase here, we saw that as price increases, the sales decrease. So that's the negative we are looking at here, which shows the strength of the association. It is 0.305, and the direction is a negative. So the other question is about is this value here that we are seeing, this correlation coefficient, is it statistically different from 0? So during the interpretation of your results, here, these are the hypotheses that you're looking at. The null's hypothesis says the population correlation coefficient rho is equal to 0. In other words, there is no correlation at all between the price and the sales. Whereas the alternative says that rho is not equal to 0, meaning there is some correlation between these two variables. So we need to look at the p-value if we are to interpret whether that correlation coefficient that we've obtained, is it significantly different from 0? Is there really a statistically significant relationship between the two variables? In that case, and from our output, we can see that the significance, the total significance, the p-value is less than 0.001. And that value of less than 0.001, if we look at this, if the p-value is less than 0.005, it is supporting the alternative. So we reject the null which says there is no correlation. In other words, there is correlation. There is a relationship between price and sales of cars. If the p-value was above 0.05, then we would fail to reject the null which says there is no correlation. In other words, it would be true that there is no correlation if the p-value was above 0.05. So let's go back to our output. On this output here, these are the confidence intervals. If you repeated this experiment by picking 155 participants 100 times, 95% of the times your correlation coefficient will be between negative 4.44 to negative 0.155. That's what our interpretation is. Or you are 95% sure that although I've gotten 0.305 in my sample, the true value in the population out there lies between negative 0.44 to negative 0.155. That's the interpretation. So in that way, you've really run a Pearson's correlation analysis, and you've interpreted the results. How do you now report those results? So you would simply put it, a Pearson correlation coefficient was computed to assess the linear relationship between price and sales of cars. There was a negative correlation between the two variables, with the correlation coefficient at degrees of freedom. Then we put here negative 0.3. Then we have the p-value less than 0.01. Usually, the degrees of freedom are calculated by n minus 2. Your sample size minus 2. I want you to note that in our analysis, we had a total of 157, but our correlation is based on 155 because correlation will only take up values that have participants that have values on both variables being correlated. We saw that we didn't have two values under price in thousands, so even the other two people who had values on sales, the other two cars, sorry, they had to be left out. So always ensure you have complete data. So that is how you would run a Pearson's correlation coefficient if you have normally distributed data. What if you didn't have normally distributed data? How would you run a Spearman's rank correlation coefficient? It would be the same way. Simply go to analyze, correlate by variate, and then same way the variables are there under correlation coefficients. If our data is not normally distributed, we are interested in taking Spearman's correlation, so I will uncheck Pearson's. I leave everything as before, and then I click OK. So in this case, they will be giving me Spearman's rank correlation coefficient, and the value is a bit different. The other one was 0.305, then this one is 0.492, but both are negative and are statistically significant. Confidence intervals will be a little, these ones are a little bit wider. So for the Spearman's, we also saw previously that you would use it when you have ordinal data. But if you have many concordant pairs, or you have smaller sample sizes, we said it is Kendall's Tau, which is more appropriate. So to get Kendall's Tau B correlation coefficients, you would still go to analyze, correlate by variate, and leave everything the way it is, and just select Kendall's Tau B correlation. In this case, you also continue and click OK. So you will have Kendall's Tau B correlations and their correlation coefficient. They are all statistically significant because the p-values are less than 0.05. You can see the confidence intervals are different. So you have to know, when do I run which type of correlation analysis, which we've already covered in our previous video. You can check the link is on top of your screen. So far, we've learned how to run Pearson's correlation, Spearman's correlation, and Kendall's Tau B correlation. So next, we shall see how to run partial correlation. So consider liking and subscribing to our videos so that you do not miss out any of our episodes. See you in the next video.